So there are different methods to solving quadratic equations. We've already looked at the factoring. We've looked at graphing. We also can solve quadratics by square roots. Now, you can only use this method when it fits a certain form. So quadratic equations of the form ax squared plus c equals 0, those we can use this method, and it's simple and it's fast. Notice it's missing your linear term, right? That's what it's missing. So when we have no term, we're going to use the square root method to solve it because it's fast and it's easy. So what are our steps here? Well, we want to isolate our quadratic term, which is that squared term. So over here, I need to get my constant term on the right-hand side. So I'm going to add 49 to both sides. And I get x squared equals 49. And then we do inverse operations, which is taking the square root. So we actually did this last year. So I'm going to take the square root of x squared and the square root of 49, and I get x equals negative 7 and 7. Remember, a negative 7 times a negative 7 can be 49, and 7 times 7 is 49. So you have two answers here. Make sure that it's a bracket form, least to greatest, because we have more than one answer. So let's do some practice problems together. We're going to start with number 6. All right, I think we're going to start with number 6. So I'm going to isolate the x squared term. So I got to get rid of the 6. So I'm going to divide 6 by both sides, and I get x squared equals 9. Now that my quadratic term is the coefficient of 1, I can take the square root of both, and I get x equals negative 3 and 3. Don't forget, it needs to be in bracket form, negative 3, 3. Okay? All right, let's take a look at number 8. So remember, to get x squared by itself, I take the multiplicative inverse. So I'm going to multiply both sides by 4/3. Whatever you do to one side, you do to the other side. And I get x squared. 3 and 48 can cross-reduce to 16. 16 times 4 is 64. So we did this a lot last year. I'm sure you don't need a refresher. And then we take the square root of both sides, which is x equals negative 8 and positive 8. Don't forget, brackets least to greatest. Okay, let's try number 10. All right, when you have number 10, I'm still getting my quadratic term by itself, so I'm going to add 45 to both sides. You get 5x squared equals 45. Divide both sides by 5. X squared equals 9. Now I can take the square root and the square root. X equals negative 3 and 3. Don't forget, it must be in brackets because it's more than one solution. And remember what these solutions mean. It means where that graph crosses the x-intercept. That's it. Now let's take a look what happens when my numbers don't come out so nice looking and they come out as irrational solutions. Not a big deal because we did this skill last year. So if you look at number 17, I still want to get 3 by itself, and I get x squared equals 3. I still take the square root, and now I just have this irrational number. So you have to remember that it can be negative square roots of 3, because I can't simplify it, and positive square roots of 3. So I just keep it there, but it's plus or minus square roots of 3. So a negative square root of 3 and a positive square root of 3. Let's take a look at number 20. So I still want to isolate. That doesn't change. So add 16. When I do that, now I take the square root of 75. So x equals, I can simplify square roots of 75. So remember when we simplified these square roots last year? It took 2 numbers to circle and come outside. So I'm going to factor this out. 5 goes into 75 15 times, and then I have 5 times 3 is 15. So underneath that square root, I would have 5 times 5 times 3. Remember, because it's squared, it takes 2 to come outside that box. So 5 comes outside, and then you have square roots of 3 left over. And remember, it's plus or minus. So x equals plus or minus 5 square roots of 3. And I tell students, you may want to get in the pattern of doing negative 5 square roots of 3 and positive 5 square roots of 3 to remind yourself that it's two separate numbers, okay? All right, let's do number 22 together. We'll do 22 and 24. I'll move it up so I don't have to do it. All right, so let's look at that. So 22, I'm going to subtract 8 on both sides. And I get negative 3. When I divide both sides by negative 3, I get x squared equals positive 10. So when I take the square root, I can't simplify square roots of 10. So I know that my answer is just going to be plus or minus square roots of 10, meaning you've got a negative square roots of 10 and a positive square roots of 10. Okay? All right, let's take a look at number 24. I'm going to add 11 on both sides. 36. Multiply both sides by 2, and I get x squared equals 72. When I take the square root of 72, I've got to simplify it. So when you simplify square root of 72, I start by 2, so I get 2 and a 36 and a 6 and 6. I recognize that this is a perfect square. So last year, remember, if you recognize it's a perfect square, that's great. Your answer would be 6 square root of 2. But let's say we don't recognize that. That's okay. Keep breaking it down. 2 times 3, 2 times 3. So underneath that square root, this is what we have. You have 3 2's and 2 3's. And remember, it takes 2 to pair up and go out. 2 to pair and go out. So I have a 2 times 3, which is 6. And underneath that square root, I have 2. Remember, it's plus or minus. So my answer is going to be negative 6 square root of 2 and positive 6 square root of 2. You have two separate answers, okay? Real quick, let's do 23. I want you to see number 23. So I'm going to add 10 on both sides. And I get negative x squared equals 28. And then I'm going to divide because x squared needs to be positive. So I'm going to flip it and I'm going to flip it. Now look at this. Are you allowed to take the square root of a negative number? No, that is irrational. We are only dealing with rational numbers in algebra. So this one is no solution. You cannot, under any circumstance, you cannot take the square root of a negative. If your negative is inside your radical, you can't do it. So it's no solution. Okay, so if you're struggling on this, come and see me.